Okay, let's get started here. Good morning. Oh, morning.
Morning.
Oh, look there, thank you. Chapter 6 and 7 go together. So there's a 6 and 7 learning guide out there. If you got a color printer, it might help. The quiz for 6 and 7 is together. The last 16 problems are reviewed. So there's actually 50 questions on that quiz. So if you go into Canvas and grab it, make sure you download it. And then if you are ahead and you've got stuff done, it actually looks like this here. Do I have it up? Yeah. So it's on electron configuration notation and quantum numbers and things like that. There's some questions in here directly from Al, but then it's the last, I think it starts on 34 here. Yeah, 34. These are some reviews. It's got some formulas of compounds, so grab your pink sheet and things like that. So the last ones are review from 6 and 7 quiz. Okay, so this is Friday. There is a possibility that if you have to be gone Friday, you can take it early. You have to talk to me though. Please don't just do it out of, it's going to be more convenient for you, because it's not going to be more convenient for me. So talk to me if that is the situation where you have to miss Friday. Okay, let's see. Do we have any questions? We'll finish up this today for sure. And then this quiz is due Wednesday, and our chapter 5 part 2 is due Wednesday, right? Okay, do you have any questions on this quiz? We didn't do 15 yet. That'll be today. And I gotta switch the order of 15. So I'm gonna switch 15 to after 16 and 17. Okay. Otherwise, 16 and 17 look very similar to what Owl did, right? Just the two of them that look good. Okay, let's see if I can somewhat redeem myself. I had this up here, and I think, and then I got lost looking at this because I don't have it highlighted, but I did. This is where I messed this whole thing up, and then I came in. I just wrote it this morning. And then I thought, oh, I have it, but there's a CLF, there's a CLF3, and it's just a mess. So I am going to go back to my highlighter and see if I can figure this out yet. So, and make sure I grab the right color and highlight the right color. So I have CLF, just CLF. I've got a CLF here. Is that the only CLF3 needs to be on the right. I think this is my CLF3, and it might be the right number. And then I need F2 on the left. That I have a half F2. Where's my other? I must have some more F2 somewhere else. Where is it? Not looking good. Did I write something wrong here? Reverse 1/2 of that one up here. Oh, I'm missing my 2. No wonder. There's a 2 right here. No wonder that doesn't look good. I missed this 2. That's this 2 right here. Now, the rest has to cancel out. So we have 1/2 CL2O on the left on this first one, and we got a 1/2 here. So I should almost, I don't know if I'm going to put more colors in there. That's going to mess it up. Let's see what we got. I'm going to lightly do this. And 1/2 CL2 right there. That matches. Wow. We got 3/2 OF2 here. This seems to be, this thing's got to disappear, right? So we have 3/2 OF2 here. We got 1/2 there and 1/2 there. That's 1. We need another half somewhere. What happened? What did I mess up? I think, right? Yeah. I need 1 1/2, and this only gives me 1. So I must
For
have.
the first one, it's 2 OF 3, so divided by 2, we only give you 1 OF.
Is it this one right here should be a 2?
Nope, the first one,
Oh, down here?
so the very first one, right underneath, use the reactions to determine. There's a 2 OF 2 up there.
Oh, where's that thing? Oh, right here.
So divided by 2, we only give you 1 OF 2, not 1/2 OF 2.
All right, so, and then over here, yes, so I'm missing. Is this, no, that's not the one. This, I'm missing the 2 as well. This is where it is, right? I'm missing this 2. Right there. That gives us 1. That does it. I better start highlighting my tools or something with another color. So yeah, I was missing a 2 right there. So now I've got 1 there, 1/2 there. That gives me 3/2 with the 3/2. The O2's got to disappear. I have 1/2 O2 and 1/2 O2 is 1 O2 and a 1 O2 here. I think that's it. So I have a CLF here, which is what I want. So here's what's left on this side. CLF plus an F2 right here. And CLF3. And if we add everything up, what do we get? What do we get if we add all that up? I'm going to double check here. Negative 139.2. Negative 139.2, yes. That look up. Okay, so that is Hess's law again. We don't have to do this reaction. If we have other reactions, we can manipulate and add up, subtract, multiply, divide to get the same reaction we're looking for in here. Okay, so one last heat value concept is enthalpy of formation. So the enthalpy of formation, you'll see a little F for that. And right here is the symbol for it. This is the enthalpy chain for a reaction in which exactly 1 mole of pure substance is formed from free elements in their most standard states. Under standard conditions, 25 degrees Celsius, the enthalpy of formation values for the elements in their standard state is 0. So how much is it going to, how much energy does it take to form gold? 0. You can pick it out of the ground if you're lucky enough, right? Oxygen gas is in the air. So down here, you see the standard enthalpy state of 0. Elements in their most standard state. Here, another one is carbon's most standard state is just solid graphite, not diamond. Now, also, if we had pressure, we'd be 1 atmosphere of 1 mole, 1 molar solutions. An example of that would be like, if we did this, carbon solid plus O2 gas, we would get CO2 gas. Well, this is 0 and that one's 0. This would be how much energy it takes to form CO2 gas. There is a table for this in your book. Another enthalpy is called the bond enthalpy, but we don't cover that in this class. So there's just a table. It is how much energy to form compounds from their elements, enthalpy of formation. Now, most enthalpy of formation values are negative, indicating that formation from the elements are exothermic. So how do we do this? This is a mathematical summation sign. So we are really doing products. We are adding up all of the products minus reactants. How much energy would it take to form everything that's on the product side, and we subtract how much energy it takes to make everything on the reactant side? N is just the balance coefficient. So let's go in and explain this with this example, okay? So we want to figure out what the enthalpy of formation is for this reaction using standard enthalpy of formation values, and I have them right here. This is in appendix, if I have it on here, it's appendix G. It's in the appendix in the book, enthalpy of formation, you'll see it. Okay, so let's do this. Again, it's a summation, and we want to do products minus reactants. So over here, let's start with our products. And obviously over here is reactants. And it's how much to form each one of these. So here's how it works. I'm going to put a big, got enough room down here. I think I'm good enough to make a bracket. And here we go. So this, we are making 2 moles of HNO3. And the state matters, it's aqueous. And HNO3 aqueous, negative 207.4 kilojoules per mole. Plus, we're just going to leave it like that because we're going to be able to punch in our calculator just the way it is. 1 mole of NO gas. And 90.25 here. (9.25 kilojoules per mole. Now that's it for products, right? So I'm going to close my bracket. All of this is my summation, right? Summation of product. I need to put a big subtraction sign here. I'm going to do the same thing for the reactants. Products minus reactants. Another bracket here. And then on the reactant side, doesn't matter which order we do it, but here is 3 moles of NO2. And 30 NO2 gas, 33.2. Plus 1 mole of H2O. And that is a liquid negative 285.8. Close that up. This is my reactants. Grab your calculator, see if you can crank this baby out. And I did just put in parentheses in my calculator just for the products minus reactants. So I only used parentheses in my calculator where I have them red, the brackets. And it'll do it in one step or without writing everything else down. So should get negative 138.32. Yeah, it's at negative 138.32. Get some vertical now, it's good. So this is the most efficient way to do this, because you know it's going to do this multiplication first, then it's going to add this. So that's going to take care of the products, and it's going to do this multiplication here. I went plus the negative and negative. Negative 138.32 kilojoules. And we'll just do one more. It should be the same exact process, same exact thing on the next page here. Let's see what we got. Oh, no, we got, oh, this is the way Al does it. Yep. Obviously, we got to settle up a bigger horse, I guess. I'm just seeing that I have a question mark here in my table. So that means we're going to solve for this. So the standard enthalpy of formation for the following reaction was found to be negative 1125.2 kilojoules. What is the enthalpy of formation for NO2 gas? Okay, notice that hydrogen gas is not on here. If it is not on here, then we know that the enthalpy of formation for hydrogen gas is equal to what? 0, right? Okay, let's see if we can solve this thing. We're going to do the same thing, products minus reactants. So I'm going to put my bracket here and start my products. And on the product side, bring it down like this. We have 2 mole of NH3 gas. And looks like negative 45.91. Plus 4 mole of H2O. And so we got negative. Now this is H2O gas. I should have put, it's different for a gas versus a liquid. So this is negative 241.8. So I'm going to close this bracket. Then I know that this is my products. And then we'll go minus reactants here. And this, let's see, NO2 gas, this is what we got to solve for, right? So we have X, I should put that in a different color. I don't know, we have X kilojoules per mole. Plus seven mole of H2 gas. This is the most standard state, so this is 0 kilojoules per mole. Now, we know how much energy we would get out of this. And that is given to us up here as negative 1125.2 kilojoules. Well, it looks like the best thing to do is solve that product number, huh? Let's see what we got. Let's keep track of signs. So grab your calculator. Let's get that product number. Looks like the product bracket is negative 1059.02. Okay, so we got negative 1059.02 in kilojoules. And minus this bracket right here is simply going to be 2 times X, right? Because moles are going to cancel out. So we simply have minus 2x equals negative 1125.2 kilojoules. So my cheater's algebra tells me to put this on the other side of the equal sign, make it a positive 2x, put this negative on the other side of the equal sign, make it positive. So I would end up with negative 1059.02 kilojoules plus 1125.2 kilojoules is equal to 2x. So 66.18 is equal to 2x. So 33.09 kilojoules, I should put my units. Of NO2 gas. So that's not super ugly. Maybe not super pretty, but not super ugly, right? It's not that. So this finishes up out. This is what you do if you're up to date and everything. This should be just the last part of out. Chapter 5, part 2. Okay. Any questions? You can now do. You should be able to finish up the last. There is only, let's see, I even had you solve for X. I don't even know if I did. There's only 2 problems now, I believe. It's 15 and 15 and 18. So, which is kind of like that. So you should be able to finish this off. Now for the test, I did 10 questions from each chapter. If you want a good idea of test questions, redo these quiz questions, right? To study for the test, redo the quiz questions. Make sure that you can do these problems, and you might just cover it up. And to study for the test, you need to write these out from scratch. So cover this up and just see how fast. You need to just go through this without hesitation, right? But I'm not just blowing you smoke. I used to study for a chemistry physics test. I'd go to the library and I would just redo problems. You don't necessarily have to punch them in your calculator. If you know how to punch them in your calculator. If you've got this much written out, once you get to this point and it matches what you previously did and you got the right answer, you could stop right there, right? That could be efficient use of study time. Go on to the next one. So I'd start doing my problems. I'd get tired. I go to the pop machine, which is now, what's this? Vicky Lord Larson Hall. There's a pop machine there. I'd have a Mountain Dew. I think I chugged down 2 Mountain Dews, but I don't know what time it was. 5 o'clock. Then I'd go study. About 8 o'clock, I got tired again. I went back to the same pop machine. I had 2 Mountain Dews. I went to the library and studied again. It was probably a 4 Mountain Dew night. I started that a couple days before the test, not the night before. Did I do the same thing the night before the test? Yeah, I did. But I started the whole sequence a couple days before the test. So please, studying for the test is writing out this, not looking at it. You can't study the test. You know, I'm studying for my chemistry test. It probably doesn't work that way, right? It probably doesn't work that way. Okay. Again, I did 10 of each. If you find yourself doing a problem and it's taking you way longer, then redo that problem. And to tell you the truth, what I actually did is I would, depending upon what I was studying, I photocopied the blank. I think I got the blank quizzes and I put them in sheets of paper. I put them in a pile, I drew them out. Can I do the problem? If I can do the problems, and I put all of them together. If I can do the problems, I set them in one pile. If I couldn't do the problem, I set them in another pile. When I got done with all the questions, I started grabbing from the pile I did not know how to do. If I didn't know how to do it again, I would look it over. And if I knew how to do it the second time, I'd put it in the ones I know how to do pile. If I couldn't do it the second time, it went in the pile I don't know how to do. Until finally I got done with everything. That's what worked for me. So you have to figure out what works for you. I never could study with a partner for the test. I always loved to do homework and stuff like that with somebody else. We usually had a couple people. We would do the homework together. But somebody would tell me, hey, you want to study for a test? That never worked for me ever, because I was just focused that I was going to redo problems and stuff. So, but you have to figure all that out, hopefully. But the only way to study for tests, redo problems over and over. Okay, questions? Yes.
Is it just chapters 4 and 5?
It is just chapters 4 and 5. That's it. Just chapters 4 and 5. Yes, Ben.
What types of equations do you need?
Anything you come across on the quiz. Q is equal to MC delta T. Know how to do the enthalpy of formation, products minus reactants. Obviously, there's going to be limiting questions, right? The other equation that just comes to mind is there's a dilution problem, right? And there is the one long problem on the chapter 4 quiz where you have to figure out the amount, the percentages, or the empirical formula or molecular formula, the CXHYOZ problem. That one's kind of a long problem, right? But that is on your quiz. So as you're studying your quiz, if you struggle through that one, you just know you have to go through it a few more times, right? So that when you are calculating this out, it just, everything goes efficiently because you have 20 problems to do in about 50 minutes. So you figure it work. You got about 2 minutes or so. Now, I did not put any, and I had to take some off if it was too long. So I took the question off on first law of thermodynamics, where it's kind of a nitpicky work, whether or not it does work in heat. You know what I mean by that? First law of thermodynamics. I took that one off. There's only one pH one. You should be able to get that. Okay. Let's look at the next. Let's look at what we're going to do next here. I printed last night. My printer does not have yellow. My printer actually looks. If you got a decent printer, okay. Now, we for chapter 6 are looking at the structure of the atom. If we're looking at the structure of atoms, we are going to be concerned about electrons in this chapter, chapter 6. Remember, in chemistry, you can never trust an electron. There's too many different things the electron can do. Again, I should have been a math teacher because 2 + 2 is always 4, but the electron can do different things. That's just why, depending upon what it's combined with, sometimes iron can be 2, sometimes iron can be +3, right? It's all what the electron does. So, chapter 6 starts out with electromagnetic radiation. So electromagnetic radiation is electromagnetic waves that travel the speed of light. So if I turn this, these are all electromagnetic waves. Starting out down here with radio waves. Now, we know that the speed of all these waves is exactly the same, the speed of light, which is very, very fast. The speed of sound, very, very, very slow. Even, I had some video clips blowing up the side of a mountain. The side of the mountain explodes. I mean, I don't know how many. By the time the sound makes it to the camera, there is a delay, correct? Where you're sitting in a movie theater and you watch something blow up on the screen, you don't want to hear the delay. So what's Hollywood do? They fix that, correct? All of the sound has been fixed when they do something like that. The speed of sound is very, very slow. I know that I can talk to my father who lives in Florida on a cell phone. I know that signal is going the speed of light. He's watching the Green Bay Packers on his TV in Florida. I'm watching it here. That whole TV signal, our cell phone signal, everything's in sync. It's pretty, I mean, the speed of light is very, very, very fast. Now, there's two properties of the wave. We have a wavelength. Anytime that wave repeats itself, so there's a couple ways to do it. If I start right here, I'm concerned about where's my wave going to start going up like this again, and it goes like this, and it starts up right here. So you could say this distance between here could be a wavelength, or you could go peak to peak on top. So as we go to the right, we have microwaves. You see that we get more waves as I go to the right. The frequency increases, the wavelength, the distance here between the crest to crest gets less and less and less. Now I go to microwaves, then this is an infrared wave. This is the old infrared IR remote controls. Now your remote controls, if you have a Roku or something like that, actually goes through your network. But the old remote controls, you needed a line of sight, correct? You need now, like my Roku remote, I can sit there and click it out in outer space and I don't have to point it to the TV at all. The old infrared remote controls, you needed a line of sight. That was that wave here. Then we run into visible light. Now, visible light is very, 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 very small portion of the electromagnetic waves. Then we get into ultraviolet radiation, UV, and finally X-rays, gamma rays. Now, this is what Al does in the very beginning. This will answer, oh, I don't know how many Al questions, a lot. So this is nanometers. So this 700 right here would be 700 times 10 to the minus 9 meters. So this would be 400 times 10 to the minus 9 meters. As we go this way, just looking at my wave over here, what is increasing and what is decreasing? As we go this way, there's more waves packed in. This is higher frequency. This then is shorter, F for frequency. This is a symbol for our wavelength. As we go that way, listen to this statement. Frequency and energy go together. This is your first questions in out. Which one of these has the highest energy? Well, it's going to be violet light, has the highest energy. This also is equal to energy. So here, if I did it here, man, if I go this way the same way, again, energy increases. Frequency increases. Wavelength decreases. Okay. Let's go to the first page. We'll keep this in mind. First page, I filled this all in. We used to fill it in class, but James Clerk Maxwell, 1864, developed his theory of electromagnetic radiation and showed that light was the visible part of the vast spectrum of electromagnetic waves. These waves travel through a vacuum at a constant speed, symbol C. We're going to round this to 3 × 10⁸ meters per second. Waves are characterized by lambda. This looks like an upside down mirror backwards Y. I don't know, mirror Y, upside down Y in the mirror. Yes. Then wavelength and then frequency. I cannot handle this. I'm putting an F in here for frequency. I put an F for frequency. It's the goofiest I'll use. This is supposed to be mu, but we're just going to use an F. Now, amplitude is just the height of the wave. Now, it might be a good time to talk about one thing you do know, and that is sound, probably. So, don't write this down, but let me show you this. So, we know that you have all adjusted a speaker. So, if I draw this out correctly, that speaker has a cone like this, and there is a back piece like this, and that back piece is just a bunch of coiled wires. It's an electromagnet. So I got to make my cone, and my cone goes back into here, and there's some windings in the cone as well. So what happens is, when you turn up the volume, all you're doing is sucking the cone farther down because you're increasing your electrical current in these windings, and then the cone sucks in and it snaps back, right? It is no different than a drum head. If you hit the drum head harder, it is going to indent more, but when it snaps back, it's going to push more air molecules. So every time a speaker snaps back, you get this compression region of air molecules. So this is where the cone snaps back out. Then the cone's going to go back in. You're not going to have much air at all. And then it's going to snap back out. If you turn up the amplitude or volume, what are you doing? Is you're making that speaker suck in farther. When it snaps back out, obviously, it's going to push more air together. In fact, it can push so much air together, the idiot next to you at the stoplight's car is shaking, and maybe yours is, right? And then this enters your eardrum, and if too much enters your eardrum, you can blow your eardrums. I mean, it's very, very wicked, and unfortunately, I wish there was a quick surgery for that to fix hearing loss, but hearing loss is permanent. They do not have a quick fix. Otherwise, I'd be getting in line pretty soon right now, to tell you the truth. So those speakers, if you have, and you can stand in front of speakers, and some of you have done this, and you can feel the air hitting you, correct? So, and then if you have a big fancy speaker system, you have something like this perhaps, and you've got some big speakers here, and then you've got some medium speakers that look like this, but then you've got these little tiny ones, or you have a horn up here. That's because that snapping back of these big speakers, you can only do that 20 to maybe 800 times a second. If you send a bigger frequency through there, it's not going to be able to snap back and just flops. So then you better send the next frequencies to these, and eventually you get to these, and these will probably do, they say the threshold of hearing goes up to 20,000 hertz. There's no way. Who can hear over 20,000 hertz? Dogs. There's a dog whistle, right? So these speakers are going to snap back maybe 20 to 800, then from about 800 to, I don't know, 11,000. These can snap back, but this is going to be 11,000 up to probably, well, I can put them in here. Well, I did that wrong. 20,000 is going to be these. You need a really, really small speaker for that thing to snap back 20,000 times a second. That's why your speakers get smaller, to get your high frequencies. And we know sound travels slowly, but amplitude, you could put a wave into this. The amplitude is how much the speaker is sucking in, and then how much air it's then pushing together when you turn up the volume. Now, when we come back, then we will go over this. I know some of you maybe haven't got this printed. If you can get a hold of a color printer, I'm going to do another printout. It would look nice to maybe get this in color a little bit. All right, so we will see you next time.
Yeah.